Hello, this is the third video of the Linear Programming 2 series on the simplex method and integer programming for OCR Discrete further mathematics. And we will see how to set up a simplex tableau based on the augmented form of a linear programming problem. We will use a two-dimension problem initially and progress to a three-variable problem later. So here is a linear programming problem with decision variables x and y, and it has three constraints, or linear inequalities. So this is the objective function, and these are the constraints, including the non-negativity. If we graphed this, it would give us the feasible region as shown in the diagram. So first we need to convert this to an augmented form by introducing the three slack variables S1, S2 and S3. This gives us x plus y plus S1 equals 12, 2x plus 3y plus S2 equals 30, and 2x plus y plus S3 equal to 20. And we know that x, y, z, S1, S2, S3 are all greater than or equal to 0. We also need to rewrite the objective function so it has a 0 on the right hand side, and this would give us p minus 10x minus 9y equal to 0. Note we've graphed the lines and I've made the colour of the line match the colour of the text to make things clearer. Let's have a think about what is actually going on. If the simplex method starts at 0, 0, at this point x equals 0 and y equals 0. If it were to then move along to the point 10, 0, we still have that y equals 0, but x no longer does. However, looking at that, it lies on the green line. And therefore, if x is 10, we will have that not only will y be 0, but also S3 equals 0. Moving up then, for example, to 8, 4, that is on both the red and the green lines. We can see that neither x nor y is 0. However, we will have that S3 is 0, and also, looking at the red line, that S1 will be 0. We could check this by putting in the values. So for example, 8 and 4 plus 0 would indeed equal 12. At the point 6, 6, this is where the red and blue lines intersect, and so we would expect S1 to still be 0 and also now S2 to be 0. At this vertex here, we have that x equals 0, but on the blue line we would also find S2 equals 0. So you can see that with these slack variables and the x and y variables, that at each vertex of a feasible region, two of the variables will be 0. And it's important to note that when the slack variables are 0, the constraints are at capacity. It is also worth noting that with the objective function up here and these three equations, we have 4 equations in total, but at the moment no way of solving them because we have more than 4 unknowns. We set up the initial simplex tableau to incorporate all the information in these four equations. So here we have the top row of the tableau already set up, and we can see that we've put in the variables, so p, x, y, s1, s2, s3, and then what we're calling the right hand side, sometimes known as the value column, which will be the values where on this what we call the right hand side. So looking at that first equation, we have one lot of p, we have minus 10 of x, minus 9 of y, no s1, no s2, no s3, and a right hand side value of 0. So we've input this equation into the tableau. The top row is always the objective function. We then put the constraints in below. It doesn't matter so much what order they go in. So we've got no p's in any of those three constraints. It's important to make sure that you get the right numbers under the right columns. So 1x, 1y and 1s1, no s2, no s3 and the value of 12, and we have input this equation. In a similar way, we would, making sure we haven't got any s1 and we get the slack variables correct, input the next two constraints. And there we have set up the initial simplex tableau. When you are setting a tableau up for yourselves, do leave some extra space over here to the right, as you will see that we need that for later working. So this tableau now contains all the information from the augmented form of a linear programming problem. Do remember to align the input and column headings carefully, and do also be careful with any signs. In the next video, we will perform iterations on this initial simplex tableau.